Today, lesson 6-9, inverse proportions. Look at that objective. You can solve inverse proportions. So, what is an inverse proportion? And I'll tell you right now, there's some different ways you can set these up here. I'm not going to be busting your chops about how you set these up, as long as you're using a ratio. Okay? As long as you establish a proportion that's correct, I'm cool with it. But inverse proportions, okay, all the proportions we have done so far, and you will see some questions in your homework. I don't know if I put these types of questions on the quiz and test off the top of my head. I don't think I did. But you will be tasked to identify, is the proportion a direct proportion or an indirect proportion? So we should probably figure out what an inverse proportion is. So most of the things that we have done to this point here, as one item increases, right? For example, if I go back to the table and I say 3 white socks, 5 black socks, and 24 total socks, as we go through it here, 3, 5, 8, 6, 10, 16, 9, 15, 24. So, as one item, in this case white socks increases, black socks increase as well. And everything we've done so far has followed that rule. Whereas one item increases, the other one increases proportionally. Right? Everything we've done has been like this. So those are called direct proportions. When one item increases, the other item increases as well. Obviously, the total is increasing. We're increasing both sets of quantities, and total, of course, needs to go up too. All right? So that's what direct proportions are. Inverse proportions, on the other hand, are different in the sense that as one item increases, the other item decreases. Right? So as one thing goes up, proportionately the other one's going to go down. So you're probably thinking, well, what are some situations where that makes sense? Okay, so I will give you an example here. So we're going to talk about a farmer, right? And our farmer friend has enough food to feed his goats for 2 days. Right? Feed 2 goats for 32 days. Right? Farmer has enough food to feed 2 goats for 32 days. Now, say all of a sudden the farmer gets more goats. Say now he has 4 goats. Right? So if I had 2 goats, and 2 goats I got enough food for 32 days. If I get 4 goats, does that mean I'm going to have enough food for 64 days for them? Well, no, obviously not. Because now I've doubled the number of goats I've had, which means the amount of food I'm going to have is going to decrease. Right? So as the number of goats, now say for example I have 8 goats. Well, once again, assuming I don't buy any more food, now I would have enough food for 8 days to feed the goats. So, as you can see here, as the number of goats increases, the amount of food and the number of days I have for the goats decreases. Right? So as goats increases, amount of food I have available decreases. Right? So this is an example of what an inverse proportion would look like. Right here. All right? So when we're looking at this here, right? Basically, we've doubled the number of goats each day, right? 2 to 4, 4 to 8. If I kept this going here, and I could, if I went 8 times 2, got 16 goats. What's going on this side here? 32 to 16. You could say I'm either dividing by 2, or you could say I'm multiplying by 1/2. Whichever method, girls, you paying attention?
Yeah.
Okay. You're either dividing by 2 or multiplying by 1/2. So 32, 16, 8. So what number would this be here? Yeah. Once again, either I'm dividing 8 by 2 or I'm multiplying it by 1/2 there. If I had 32 goats, how many days of food do I have now? 2. Exactly right there. Exactly right. So what you've noticed going on here, and I've used this term before, is the quantities, when we're dealing with inverse proportions, change by reciprocal factors. Remember what a reciprocal is? All right, reciprocal. What's the reciprocal of 3 over 2? 2 over 3. Right. What's the reciprocal of 4? And again, you can think about it as 4 over 1. 1 over 4. So here we go. What's the reciprocal of 2?
1 over 2.
Equals 1 over 2. See? Here's my reciprocals. There's 2. There's 1 over 2. So when we're dealing with inverse proportions, the key is to remember we will be multiplying by reciprocals. Reciprocals. And everything has a reciprocal. Yeah. What's the reciprocal of 1/3?
3 over 1.
Yeah, 3 over 1 or just 3, you could say. Yep. So that's what a reciprocal is. We just flip it around. And even if it's a whole number like 3, you can convert any whole number to a fraction by merely just putting a 1 underneath it. That's how you can convert a whole number that doesn't appear as a fraction into a fraction. And then you can easily figure out what the reciprocal of any number is. Okay? So as one quantity goes up, the other quantity is going to go down, and the factors are going to be reciprocals of each other. Okay? Don't worry, we're going to practice this a little bit here. We'll practice. And this marker really sticks to the board too. Good enough. Okay. So here's a question. All right. 4 teenagers. 4 kids. 4 7th graders. All right. 4 of you guys. All right. It takes 4 7th graders a half hour to wash 10 cars. All right. Takes 4 7th graders a half hour or 30 minutes to wash 10 cars. So the question I have for you is, how long would it take 8 7th graders to wash 10 cars?
15 minutes.
Yep. But can you set it up with a proportion?
Yes.
So You can set up a proportion. Looks good. Looks good. Yep. 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 So there's a couple different ways you can do this here. So more time over less time, all right, equals more teenagers over less teenagers. All right. So I can start plugging in the information that I know. So half hour. So I'm just going to call that a half. All right, a half hour. All right. And what I don't know is it's going to take less time for more teenagers to get the work done. All right. Equals 8 over 4. All right. Now I can go through and start solving it here. 8n equals 4 times 1/2 is 2. Divide by 8, divide by 8, n equals 1/4. 1/4 of an hour is 15 minutes. So you certainly have a choice here at this point too, if you want to convert this right into minutes. So I've calculated by hour, half hour, 1/4 of an hour. But if you want to just make this minutes, all I need to do is write 30 in here. Because now I'm figuring out for minutes, right? The same process. 8n equals 120, divide by 8, divide by 8, n equals 15 minutes. Right? So you can go either way with it. So if you want to calculate it by hour, what? But as we get more teenagers, right, or more 7th graders, it takes less time to wash the same amount of cars, right? So if I double the number of 7th graders, double 2, and I multiply by the reciprocal of a half hour, 1/2 times 1/2 equals 1/4. 1/4 of an hour. Multiplied by the reciprocal. Okay? So there's a variety of ways I'm cool with you setting this up. All right? I am cool. There's a multitude of different ways to get to the right answer. Okay? I am not gonna get all stuck up about whatever method you would decide to do. Okay? So let's try another one here. All right. Who likes walking on treadmills?
Not me.
Garrett.
Uncomfortable.
Garrett likes walking on treadmills. All right. Garrett walks 3 miles on a treadmill. All right. 3 miles. All right. He walks 3 miles an hour. Okay. All right. All right. So if he walks 3 miles an hour, it takes him 1 hour to walk 3 miles, right? You agree with that? So now he said, the question's going to be, now Garrett is going to start walking. Garrett walks 4 miles an hour. Walks 4 miles an hour. So the question is, how long will it take Garrett, will it take him to walk 3 miles? All right. So I'll give you guys a quick second here to try and work that out here. So there's a couple different ways you can set this up here. Looks like a good way to set it up. I think that answer's good. Yeah, kind of. But remember, it took him 1 hour to walk 3 miles at 3 miles an hour. So if he's walking faster, it's probably going to take him less time to walk the same distance. So you know your answer needs to be less than 1 hour. If you have an answer that's bigger than 1 hour, that doesn't make sense. Right? Because he walks 3 miles. It takes him 1 hour if he walks 3 miles an hour. Now we're looking. So now Garrett's walking faster. So this is in inverse proportion. As he walks faster, that's moving up. The time it's going to take him to walk the exact same distance is going to go down, right? If you're walking 3 miles, you're going 3 miles an hour. It takes you an hour, and now you pick up your pace to 4 miles an hour and walk 3 miles. You're going to get there faster. So there are a couple different ways you can set this up here. All right, now I'm going to show you 2 different ways to set this up. Either one is acceptable. All right, either one is acceptable. Okay. So fewer miles per hour, right, over more miles per hour. So fewer equals less time equals more time. And remember, we're switching the order on these here because as one goes up, the other goes down. As one goes up, the other goes down. So fewer miles per hour is 3 over 4 equals less time. We don't know how long that is going to be, but we do know it takes him 1 hour more time when he's going fewer miles per hour. Now we use our cross products. 3 times 1 is 3 equals 4h. Divide by 4. H equals 3/4 of an hour, or 45 minutes. Okay. Another way you could set this up. Another way you could set this up, which is perfectly cool. There's nothing wrong with this either. Right? Fewer miles per hour. Right? And that relates specifically to less time. Because fewer miles per hour is going to be less time, right? Equals more miles per hour over more time. And once again, I can set in all the information that I know here. So fewer miles per hour, that I know. What I don't know is less time, more miles per hour, that I know, versus 1 hour. And I can go through and use my same process. 3 equals 4h, divide by 4, divide by 4, h equals 3/4 of an hour, or 45 minutes. So, both of these are perfectly acceptable ways to go about doing it here. But with this one, I am comparing like units, which is basically the speed that he walked. These are both speed that he walked to how long it took him. Like units. Speed equals time. Speed equals time. And as we know, as one goes up, the other goes down. So I flip the order because I'm basically going to be multiplying by the reciprocal. Right? Or I could set it up with unlike units. Unlike units. Fewer miles per hour going slower over less time equals going faster versus more time. So as one decreases, the other would increase. Right? Fewer to more, less to more. Smaller to bigger. So I can set it up either way, and it's okay. It works. Either proportion I use nets me the same result though, right? 3/4 of an hour. Okay. All right, I'm going to give you guys one to try. One to try. Messy board. Okay. All right, we'll say Bill. Bill. Right? Bill's in his car. Bill drives 50 miles per hour. Okay? It takes Bill 1.5 hours to drive 75 miles. Which makes sense. You go 50 miles an hour. Half of 50 is 25, so 150 plus 25, he'd go 75 miles in an hour and a half, right? You agree with that? You agree with that? So now the question becomes, how long does it take Bill to drive 75 miles? Bill goes 40 miles per hour. Give you guys a minute to work on that. Yeah, you're right. You just, if you left it in a fraction, yeah, if you left it in a fraction, you'd end up with a 0.875 essentially. But yeah, you're right. You're right. I'd accept that. Of course, I think technically it'd be 1.8. So, setting it up here. This is how I chose to set it up. There's, again, a couple different ways you can set this up here. But hopefully, if anything, as you're working through this here, took him an hour and a half at 50 miles per hour, right? So if we're going slower, Should my final answer be greater or less than 1.5?
Right.
Yeah, it's going to be greater. Because obviously if you're driving slower, it's going to take you longer to drive the same 75 miles. So that should at least help you out in your mind when you're working through this, where if you get a number that's less than 1.5, you can probably just use some common sense and go, this doesn't even make sense. I don't think this answer is right. Nope. So, how would I set this up? Alright. So, I'm going to say faster time over here. And on this side, I'll go with slower time. Alright. Faster time and slower time. Which is good, because we know those two numbers got to be on different sides of the proportion, right? Faster time over here, slower time over here. Okay. And what I don't know over here is going, or I guess I should call this, well, call it sure, great. And I can call this faster speed versus slower speed. Okay. I could do it the other way there. Let's see if I like that then. So this way. Faster speed, lower speed, over, faster time, lower time. Yeah. So, let's start plugging in information that we know to be true. So the faster speed that he drives is 50. The slower speed is, that part's we know. And as one goes up, the other goes down. So the slower time, what's that? Well, that we don't know, but it's obviously it's going to take him longer driving slower, but we do know the faster time. If he drives 50 miles an hour, it's going to be 1.5. But, so from here, 40 N equals 75. You would get 1.875 hours, which, if you know your decimals, converts to 1 7/8 hours. So either answer would be perfectly acceptable to me. If you wrote it in decimal form, 1.88, that's fine too. You can certainly just go with decimal form. No problem. All right. So not many homework problems. 2 through 10. 2 through 10 even. So just a couple of them. So use common sense to help you solve these problems. Read carefully the information that you're given, so you at least have an idea in your head if your final answer should be greater than or less than the quantity that you're comparing.